Hey, what's up? It's Andrew here from Offshore Audio, bringing you tips and tricks to make you a better live sound engineer. Today, I thought I would talk a little bit about the various analog and digital connections that you find on the back of mixers. I'm going to talk mostly about the back of a Behringer X32 because it's a really prevalent mixer in smaller venues. So by the end of this video, I want you to be able to understand what all the connections are on the back of this mixer, analog and digital. I want you to understand the difference between analog and digital audio, specifically regarding these connections here. And I want you to know when and why you might use them. We're going to look at analog versus digital audio, the analog connections on the back of the mixer, and the digital connection. And then we'll sum it all up at the end. So without further ado, let's dive in. So we need to begin by talking about analog versus digital audio. I think most people understand that sound is pressure changes, right? It's a pressure wave in the air. And our ears hear that and then translate that into information that our brains understand, right? So pressure to ears, now we understand. Similarly, a microphone translates that sound pressure into an electrical signal. And translating it into an electrical signal means that we can then manipulate that using a mixer before translating it back into sound pressure using speakers. Then the speakers reproduce the sound, our ears hear it, so on. This electrical signal created by this microphone is analog audio. The electrical signal, we often show it in a sine wave because it's a simplified method of communicating. This wave of electricity in the cable directly translates to the sound that we hear. We feed that signal into the speakers, then they've reproduced the pressure changes and we hear it. And in that way, a high level signal translates to a loud noise and a low level signal translates to a low noise, all from this one electrical signal. As this level increases, we slowly saturate, distort, and then clip the signal. So there comes a point where you are degrading the signal quite substantially by sending higher information in. As opposed to digital, where when you cross this line, all information is lost. It's just hard clipping. So I'm filming this in 2022, and I think most people understand this concept of binary data, right? Ones and zeros. They understand that that is the language that computers understand. So obviously digital audio is ones and zeros as well. But it almost always starts as this analog signal that we talked about. That analog signal goes into a converter, which then turns it into the ones and zeros. In the past, pretty much everyone has drawn this waveform, right? This sine wave. And then to show digital information, they have done this sort of step thing to give this impression that when you convert to digital, you're losing information and you're losing fidelity. But really, I don't think the conversation is so much about losing fidelity anymore. I feel like that's a really outdated way of talking about it. And this sort of digital step diagram that we have feels pretty old to me. I think it's more important to think about this analog electrical signal as being this wave that is drawn. Digital audio pretty much always starts as analog audio, right? This continuous voltage, and is then converted into ones and zeros. But it's still a voltage within a cable, which is being sent from one device to another. I think the difference here to get your head around is that the analog signal is like drawing in the audio waveform, whereas the digital one is more like delivering an envelope with a coded message inside it, which has instructions on how to draw the waveform. Once it's been converted to digital and sent, the converter on the other side receives the envelope and says, oh, that's for me, opens it and says, all right, I need to draw a sine wave. So the thing about these envelopes, right, is they contain coded messages, and we need to break the code to turn it back into an analog electrical signal before we can turn that back into sound pressure changes. And this is really important because we need to have the right code breaking instructions to turn these ones and zeros into the right audio. If this doesn't make sense, go watch The Imitation Game. It's a great film. But this is really important to keep in mind when you think about the different standards of digital audio connection that we're about to look at, and also the different digital data connections on the back of this mixer, because it's not all audio. But let's look at that a little more in depth. So let's begin by taking a look at the analog inputs. Obviously, the best place to start would be these microphone inputs. They're on XLR connectors, so you can connect a microphone to them using an XLR cable, or you can connect the output of a DI box, because DI boxes, basically, long story short, turn other signals into microphone signals. I'm not going to get into all the other different types of signals that you could plug into this that wouldn't work. I'll leave a link down below to a module of a course that I've made where we go into that in detail. So if you're curious about that or you don't know about that, check that link out. But the special thing about these versus the other inputs that we're going to look at is that behind these XLR connections, there is little microphone preamp, which turns the volume up because the output of microphones is really low and we need to raise it up to use the mixer. Next to that, we have XLR outputs. These are not microphone outputs, these are line level outputs. Now down here, you're going to see the auxiliary inputs and outputs. Auxiliary does not mean mini jack. Auxiliary means additional or supplementary. Now these are auxiliary inputs because they're not on XLR connectors, which are the really common connectors that almost every stage input uses. They also don't have a microphone preamp behind them, so you cannot connect a microphone to them. They're mostly balanced jack inputs, but watch out for the RCA inputs because they're not balanced. Basically, don't connect a 10-meter long RCA cable with a mini jack on the other end to the mixer. The quality of the audio will be dreadful. And down here we have the auxiliary outputs. Same thing, except they're sending signals out of the mixer. Now let's really get into the digital audio connections. Let's start with the AES3 connection. Sometimes it's known as AES/EBU, Audio Engineering Society, European Broadcasting Union, maybe. This is a digital audio connection on an XLR connector. If you connect a microphone to this, you will receive no audio. Because remember, it's all about this coding and decoding of a message. So you have on one side the converter, which turns it into an AES3 signal. It encodes it in a specific way and then sends it to the AES input somewhere else, which decodes that message. It says, I see that it says AES3 on the envelope, and I happen to have the information to decipher this code, and I can turn it back into translatable audio data. With AES3 data, you need to have a specific cable, 110 ohm cable. Otherwise, your data is going to fall apart after about 10 meters or so. Remember we looked at that coded electrical signal? Well, over time, it degrades and the edge is round and it's impossible to decode the message. You might get away with it over a few meters, but I wouldn't try it in any sort of situation over 10 meters or so. Let's take a look at the next most important digital connection on the back of this mixer, which is this AES50 connection, right? Because that is what we use to connect our stage boxes, isn't it? Notice that this AES50 is a totally different thing to AES3. AES3 is 2 channels of digital audio sent on an XLR cable. AES50 is 48 channels of bidirectional audio sent on a CAT cable, an Ethernet cable basically. Remember I said you needed to use a special cable for the AES3 connections. It's the same with the AES50 connections. You can't just grab any old Ethernet cable. It needs to be a Cat5e cable or higher. These CAT cables sort of increase in quality, right? So Cat5e is a certain point on the scale. If you use a Cat5 cable, that's not good, that won't work. But you can use Cat6 or Cat7 because it's a higher standard. You want to make sure that you're using a shielded cable though, not an unshielded cable. The signal is subject to interference, and then if you distort this electrical signal, which is a code, the code is unbreakable again, remember? And so you will get dropouts in your audio because one packet, one envelope that they receive is going to be gibberish to them. They'll be like, forget it, we don't make that into sound. Another really important thing to know about this AES50 signal is that it's not suitable for sending over a network. You can't plug it into a router and send it to multiple locations, or you can't put a router in the middle of the stage and then plug your stage boxes into it. It needs to be point to point. It needs to go AES connection to AES connection because of, again, the code that's used to write this digital signal isn't translatable and decipherable by networking switches. That brings us on to our next connection, which is on the same type of cable, right? An Ethernet cable, and it's the ultranet connection. This is a sort of invention of Behringer and Midas and all sorts of other things. Basically, it's 16 channels of audio sent along an Ethernet cable, but it's for a totally different purpose. They advertise it as personal stage monitor. I've never seen them used on a stage before. I've seen them in recording studios, but never used on a stage. Leave a comment down below if you've seen them on stages. I'd love to know about it. But essentially, it's the same cable this time, but again, the code used to encode this data into digital audio is different from the AES50 data. So you can't send digital audio from your AES50 stage box into your ultranet input. They can't speak to each other totally different codes. Next up is this USB card that we have. It comes pre-installed in all of these Behringer X32 mixers. It's 32 channels of bidirectional audio, so 32 in, 32 out. You can download a driver for your laptop. I've got some tutorials on how you can do that. I'll link to them. This USB card you can actually swap out for a Dante card. Now, Dante is another digital audio protocol, another code that's used to encode data and send it over network cables like Ethernet connections. There's loads of different connectivity you can have with Dante. You can connect Shure digital wireless microphones to your mixer with Dante. What's that I hear you say? I have a Dante enabled stage box. A Yamaha Rio stage box, for example. Can I use that with my Dante card in my X32? Yes and no. There isn't any control data sent along these Dante ports. Although you would be able to collect the audio data from your Rio stage box, for example, you wouldn't be able to control any of the functions on the stage box like phantom power or gain. It's not exactly recommended, but you could do it, and there are workarounds to it. The last things we want to take a look at on this mixer are the data connections. So these are still digital information. They're not analog information, but there's no audio capabilities here. There are no converters behind these ports. There's no one there to break the code and translate the message to the rest of the mixer. You've got this Ethernet connection, which is just for connecting a router so you can wirelessly control it with an iPad, or you could connect a PC to control it from a distance. But all it is control data. And similarly, this USB port serves the same purpose. Control with another device. We've got these MIDI connections as well, which as far as I can tell are used for controlling with pedals and stuff, the functions of the mixer, but I've never seen them used in that way. Again, leave me a comment if you have, I'd love to hear about it. So that's that for all the connections on the back of the mixer. So let's sum up why we need to know all this and why all this is important. You need to know what you can and cannot connect on the back of your mixer. You need to know that an AES3 input, although on an XLR, is not a microphone signal. And knowing what is digital and what is not also allows you to skip unnecessary analog and digital conversions. Because every time that you convert between digital and analog, you add a little bit of delay, a little latency, and a little bit of noise into the signal. So like I said with these wireless microphones, you go digital to digital with no conversion in between. It's faster and the signal quality is better. So why would you not do that? Why would you waste your time going back into the analog domain to go back into the digital domain? Similarly, you've got a stage box and you think, oh, I'll just plug this into my mixer, but you plug it into the Ultranet port. You need to know that you're not going to get any useful data out of that. The stage box is encoding the data and the Ultranet port is saying, I have no idea. I don't have the instructions to break this code. This is just a bunch of random ones and zeros. It means nothing to me. I hope that makes sense. I just wanted to give a different way of thinking about digital signals, as well as an overview of all the connections on the back of a mixer. As always, if you found it helpful, please subscribe to the video. And if there was stuff that you didn't understand in this video, I'll leave a link down below to the first module of a workshop that I made where we cover these signal types and things in detail, and you can get that totally free. For now, I'm going to say thank you so much, and I'll see you in the next one. Goodbye.